Okay, in this video we're going to look at something called substitution, okay, which is just a fancy name for something quite simple we'll see soon, okay? So let's bring back a picture of what this x plus 2 means. We have a box and 2 extra Smarties. If we were to ask what the value of x plus 2 is, well, we'd have no idea, because we don't know how many Smarties are inside the box, and what we've spent the last little while doing is being somewhat comfortable with that, okay? We don't know, but that's okay. We can still work with those boxes. But for the first time ever, we're going to do something crazy. We're going to peek inside our box. And say we find that there are actually 5 Smarties inside, right? So that's if x equals 5, okay? That means rather than think of it as some mysterious box, we've ripped it open, pulled everything out, and we've found that there are actually just 5 Smarties inside. Okay, now of course, it's not always going to be 5, it's just for this first example here. But in this case, I hope it's clear, we'd find we have 7 Smarties in total. So let's just sort of see that again quickly, sort of away from the picture. We had x plus 2, which we normally can't do anything with, but if for some reason we find out that x equals 5, or we just want to see what happens when x equals 5. Both cases are possible depending on what we're doing. Then all we need to do is grab this x guy, change him into a 5, and then it's as easy as just doing 5 plus 2, which of course is just 7. Okay, so let's see another example with something a little more complicated. Okay, we have 4x plus xy here. Now, remember, whenever we have things like 4x or like xy, okay, 2 objects stuck together with nothing between them like that, we are actually hiding multiplication signs between them. So it's 4 times x plus x times y. So now we can rewrite that using the values of x and y we've been told. Okay, so we know first that x is 2. So wherever I see an x, I would change it into a 2. Then we know that y is 6. So whenever I see a y, I change it into a 6, and there's only that one guy at the end there. And now it's just doing some arithmetic, okay? Just be careful with the order we do this in. We need to do all the times first, remember? So we have 4 times 2 being 8. We have 2 times 6 being 12. And then we can add them together. And we get 20 as our final answer. Okay, one last example. This time with some squares and negatives and stuff. Okay, so we have x squared minus 2x, and we know that x is negative 3. So what we need to do is change our x into negative 3. But I want to make sure that negative 3 stays as one single number. So I'm going to wrap him up in brackets. Okay, I'm going to show you in a moment what happens if we don't do this, but just make sure you're doing this so that the negative 3 stays as that one single number that x equals. Okay, we're going to square it, and then remember minus 2x means minus 2 times x. But again, x is negative 3, so we're going to put it there inside those brackets again. Okay. So let's do the square one first. When we square the number negative 3, we need to times negative 3 by itself. Now 3 times 3 is 9, but when you multiply a negative by another negative, okay, it flips to being positive. So we get just a positive 9 down here. Then for the next part, we have again a negative times a negative, giving us a positive, and then 2 times 3 is just 6. Okay, so really in the end, it's just 9 plus 6, and we get 15. Okay, so let's just finish by looking a bit closer into those brackets we introduced just then, okay? It was really important when doing the square. So let me illustrate using that, and we'll just say if x is negative 3, then what is x squared? Now we saw it was 9 before, but let's look into that a little bit more closely. Okay, let me show you a really, really common mistake that you want to avoid. Okay, we see this all the time. Okay, so it's good to start noticing it now. What we see people often doing is they go, well, x is -3, right? So I'm just going to write -3 here, and then I want to square it, so I'm going to just write a square there. And usually the mistake happens when they feed this straight into a calculator or something, okay? But if we write this thing in red here, what you see in red, what's going to happen is that the square actually has to happen first. So the negative gets shoved aside, then the square hits the 3, turns it into a 9 because, well, 3 times 3 is 9, and then the negative joins back afterwards and turns the result into a -9. Okay, so because of the order we do the calculations in, right, the square happens first and the negative gets left out to start with, then comes back afterwards. But of course, this is wrong. Okay, now why is it wrong? Because what we've done really is we've split the negative and the 3, and worse than that, the 3 has run off and done other things like turn into a 9 or something, and that is a disaster. Okay, because x is meant to be a single object, the single number, -3, right? And that isn't meant to be split up like that. So that's why the safest way to handle substituting negatives is to wrap them in brackets. And then we can square it. Okay, and so when we write it like that, we are squaring the entire number -3. That's what x was, okay? And so that means we're properly multiplying 2 copies of that number -3 together. Okay, that's where you can see the negative times negative giving us the +9, which would be the correct result in this case. Okay, so moral of this story is when substituting negatives, it's safest to think about wrapping them in brackets, especially when you start feeding these things into your calculator. Okay, so that's all for this one. Thanks for watching. See you around.